live.
Hello, present people, and also future people watching in the future.
Hello, hello. So let's put playing with Zig and Raylib. Raylib. Okay, so for today's stream, today's recording, it will be short. We want to implement character rotation. So basically, what does that mean? We want to go to here, and we want to uncomment that. We want to uncomment that. So theoretically, if I do just client, what? What happened? Did I do the flick here? Seems that I didn't.
Impuri.
Okay. So what do we want to do? We have this thing, and I want, like, when I press D to go to the right, I want the model to rotate, to look at the right. Same thing to all the other directions. So every time I press a key that moves the character, I want it to rotate accordingly. That's what we want to do today. And according to Marinho, the math that we're gonna use to make this happen has a special name of quaternions. Quaternions. Which I have no idea. Okay, so is this the Wikipedia
That's
page?
that's the Wikipedia page, yes.
So can you explain, Marinho, exactly what you mean?
Okay, so you know the complex numbers, right?
Yes, I do remember those from electrical engineering.
Yeah, did you know that you can actually encode 2D rotations as complex numbers?
Didn't remember that, but I guess go on.
Yeah, well, complex numbers are nice and all, but they are two-dimensional, right? We want to do a 3D rotation. So, in order to do that, it turns out that you actually need a four-dimensional number, which is called a quaternion, which has a real component and three imaginary units, which are called I, J, and K. And basically, the way you encode a rotation in quaternions, in the same way you encode is similar to how you encode a rotation as a complex number, because as a complex number, what you do is you say, okay, the angle of rotation is a point in the unit circle around the 0, 0 in the complex plane.
Yes, though that if you want to rotate 90 degrees, you just multiply by I or something.
Yes, exactly.
I
Um,
100% remember that.
yes, that is correct, and you can generalize that to any point in the unit circle. So basically any point where if you square the real and imaginary parts and add them together, the sum should be 1 because, well, that's just one square is the distance 1 from the origin. So it's a point in the unit circle.
Okay, so do you want to apply that math to this guy?
Yeah, but in order to do that, it turns out that actually you can't have proper multiplicative inverses, which you kind of want to have nice multiplicative properties, right?
Yeah.
You can't do a 3D number. That doesn't work mathematically. Which is why the next division algebra uh, after the complex numbers is actually the quaternions, which, as I said, 4 dimensions, right? You have the real part and you have I, J, and K, the 3 imaginary units. And multiplication of quaternions, similar to multiplication of complex numbers, can be used to denote rotation. Except rotations in 3D space are not actually commutative, which implies that multiplication of quaternions is also not commutative. Fun fact, it's only associative. The problem
Oh,
is,
wait. Okay, so it was in the wrong page. Vector type, there is a quaternion type.
yes, there is. Nice.
Okay, there is a quaternion type. Ah, jeez. Look, look at the name of it.
Yep. Vector 3 rotated by quaternion. Very nice. Very nice.
Ray math. Okay, can you go to the Raylib Zig and find me the definition of a quaternion?
Sure.
Actually, uh, before doing that, because this is kind of well, we're gonna have to understand a little bit in order to use it anyway. Transform a vector by quaternion rotation. Uh, oh, we don't need quaternions at all. We don't need quaternions at all.
We don't.
There is this function.
Hmm.
There is this function, which is precisely what I thought in my mind. But I would like, Marin, if you know how to do it, if you want to explain how we would rotate using the quaternions, you can go on.
I don't actually know the full details because I'm more interested in 2D. I'm more interested in 2D coordinate systems than 3D ones because I'm a retro gamer. I like 2D games. But yeah, it's basically in a similar way that you use a point in the unit circle to encode a rotation as a complex number. You can actually, if you skip the real coordinates, you are left with three imaginary units, and then obviously that's three dimensions. So if you define a sphere in those three imaginary dimensions, um, the surface of that sphere will have points that has, well, a unit sphere in particular. The surface of that sphere represents 3D rotations. And I don't fully know how to apply them. As I said, I'm more into 2D math rather than 3D, but that's the gist of it. You can figure out the details. The algebra is a bit large because you have to keep in mind the rules for the four imaginary units, but it's not that difficult, I wouldn't think.
But it's still, man. I never heard of quaternions before. But I'm very glad. Well, I'm not saying that I'm glad that I don't have to learn anything. It's just that I'm glad that um, we can have this working in a faster manner, I would say. Yeah, I would say that. So that's a thing. I don't want this to be anonymous, which sucks. I guess I'm gonna have to do it. So there will be a const character in here. There will be that. And what is that gonna be? That's gonna be, oops. Uh, that's not what I want. This is what I want. That, that. And then in here, instead of having that, which is kind of weird, it's saying it's messages character. What the heck is a character? Yeah, we need to work on the names. We definitely need to work on the names. Equipment data, and this is a texture 2D.
Yeah, you know how that famous phrase goes, right? There are only two hard problems in computer science: caching validation, naming things, and off by one errors.
I guess that's fair, but here's the thing. Where are we? Well, we have a compiler. I don't need to care, so I'm gonna just nuke this. I'm just gonna nuke this. But it's very
Nice.
concerning. This is very concerning because where are we using all of that stuff? Do I have ripgrab? Do I have ripgrabs? Ripgrab?
RG.
Ah, I
You
haven't
don't.
installed. I haven't installed ripgrab. This may take a while. Okay, so I'm kind of thinking, should we combine these things? Because I have no recollection what the heck is a recoupment data. I'm kind of thinking it's the model.
It is the model, actually.
But if that's the
I remember
case,
because the idea was okay, you can have different equipment, and depending on your equipment, you are going to render a different model.
okay, I'm gonna nuke this then. I'm gonna let it break, and then we're gonna fix in the compiler via the compiler telling us stuff. So because of that, I'm gonna make this pub. I'm gonna make this pub, and then we need another thing in here, which is rotation. Um, Position, and then it's gonna be a vector3 and that. And what that's gonna be? That's gonna be this thing in the beginning. So that's gonna be that. That's gonna be that. And we also gonna need a rotation angle. Do we need a rotation angle? I don't think so. We don't need a rotation angle because the rotation is gonna be embedded here. So that means,
I think I think the rotation angle is how much you want to rotate by.
yeah, but we're gonna save this as a you know what I mean? This is gonna be embedded because look at the function. Look at the function. This is returning a new vector 3.
Yes.
We're gonna pass the rotation vector 3 to here. We're gonna make specific const vectors specifically for each for actually no, we only need one. It's gonna be a single constant. And the flow and the angle that we're gonna rotate is gonna depend on which key I pressed. Agree?
Agree.
So we're gonna then mutate the game state to save this new vector 3 as the new rotation.
Makes sense, I guess. Well, actually, no, it doesn't because
Because
hmm, you know
go.
what? Go ahead. I'll try to think about it.
Okay. Well, if it's gonna fail right in my face. Right in my face. Uh, yeah, this is the type of shiz that Emacs. Okay, so let's open that. Oh, I keep forgetting. My Emacs is not configured to do this type of editing. That's okay. So we're gonna do this. Then what are we gonna do? We're gonna do game state, rotation. Oh, character, rotation, and then that's gonna be equal. That's gonna be equal to ray math um, vector 3 rotate by axis angle, and then we're gonna have to have, well, I'm gonna put rotation for now. Oh, that is because, oh, that's okay. I'm gonna format and it's gonna be pretty anyway. Then we're gonna have an axis which I'm gonna put uh, something like height.
Man, that looks messed up.
That looks very messed up, doesn't it? Oh, here. Angle. What the heck happened? I don't understand what the heck happened there. Boom, 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 boom. Angle, rotation, height, axis, and then there will be a number. And then I do this, and then this. And then theoretically, if I do a, well, rotation is equal to game state character character rotation. And then if I do, well, I guess what I really need is then just format. Expected comma. So there's something wrong in here. What is wrong? 19. Uh-huh. I'm just blind. Cool. And we are lacking one of these. Okay. It didn't format this. So this is valid Zig. Well, this is valid. Well, of course it is, but it's not. This is how the formatter
That's
allows
because
this to
of
happen.
that's because the rules of the formatter are like, if you don't break the line after the first curly brace, it's just gonna keep everything in the same line.
Can I just do incurrent buffer? I don't. Okay, so I'm gonna have to discover how the heck to do that. And I'm not like Margeta that wants to
Actually,
make a macro because of it.
yeah, actually, I don't. I think you can just put a line break in the first curly brace after the first curly brace, and then the formatter will do the rest of the work.
Oh, so you're saying just this,
Yeah.
this, this, and then you were saying, yep, nice. Thank you very much. Thank you very much. So
Yeah.
things are gonna break pretty phenomenally.
Probably.
Things are gonna break pretty phenomenally. So I need to change this guy to character model, and I also need to change boom, 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 boom. I need to change this to character position. I need to do that. So, so. Let's actually go to menu, character, in here, character, model. So that's correct. And I also need to remember in the main game state, we need the character. We need to have a character. That's something that I just forgot. Yeah. So we're gonna say current, actually character is equal to character, and that's gonna start. I think I can do just like this, right?
As long as every field has a default, yes.
Which is the case. Which is the case. Then we have to change this, which is hilarious. But it is what it is. So now we need to define the angle. Oh, we need to define the height axis as well. So where should this live? Should that live? I have no idea. For now,
It
we
should
can
be a
just,
constant somewhere, right?
yeah. So height axis, uh, and we need to say the type of this to be vector 3. So we need x. So what is the height axis? I think it's going to be always y, right?
Yeah.
I think we settled this before.
Should go straight up.
Yeah. So here's another question. This 270, can we get rid of that? So draw model. I really want to get rid of that. I really want to get rid of that. So what is the difference between wires and rotation draw model X? So we have the position, we have the rotation axis, and we have the rotation angle.
The normal draw model thing doesn't have a rotation at all.
Yeah, the normal one doesn't have rotation, which kind of sucks. What is the difference between wires and wires X?
Same difference, I would think.
Oh
One
no,
has
no,
rotation and the
yeah,
other
no,
doesn't.
yeah, no, yeah, exactly, exactly. Stupid. That was a very stupid question. So now let's think about it. So what will be the rotation? I'm kind of confused, to be honest. I'm kind of confused.
Hmm.
Hmm. Okay, I kind of have an idea. Yeah, I kind of have an idea. So what we're gonna
Okay.
do? What we're gonna do? We're gonna pick this if and put it at the bottom. After do all of that. Yeah, that's what we're gonna do. And the other thing that we're gonna do, we're gonna make a var here, which is gonna be angle. Alright, which is gonna be angle, which I don't know the type. I'm gonna guess it's gonna be usize. I'm gonna guess it's gonna be usize. And this is gonna start with 270, actually. Then in here, what we're gonna do? We're gonna do character, position, game state, character, rotation. Maybe rotation axis is even better. Maybe. I think rotation axis is better. And here we're gonna have angle. I think. I think.
Hmm.
Mm, I'm actually not quite sure. I don't fully understand. We want to rotate a vector by an angle, but we still need the angle. Why?
Because the vector gives you the axis about which you will rotate, and the angle is how much you're going to rotate.
Yeah, but I don't understand
Like
because
imagine, imagine you have the model, okay? Imagine you poke a very long stick through the model. That's the vector.
no, that I understand. But then we're gonna rotate the stick.
Yes, and the angle is by how much you rotate the stick, and therefore the model that is, well, that the stick is
No,
going
yeah,
through.
no, but that's the thing. We are rotating the stick already.
How can you tell? Like,
I don't follow at all. Wait a moment, man. I think there's some misunderstanding on my part because we want to use this function to rotate something in the y-axis, right? We know
yeah,
this is going to be y-axis. We know this already. What are
okay,
we rotating?
a vector.
What is this vector in the game?
It's just a vector. It's a direction and a magnitude, essentially. You're basically saying, okay, I'm going to take a stick that's floating somewhere in space. I'm going to poke a second stick through it and then rotate the second stick by some angle.
I think Yeah, I think I got this totally wrong. This is nonsense. Yeah, this is 100% nonsense. So here's what we're gonna do. Uh, here's what we're gonna do.
I wonder actually if there's a render function that takes a quaternion. That would be funny.
We don't need to do any of that. In the ifs, what we're gonna change is the angle itself. The axis is always the same. Is always height. Yeah, the axis is always the same. That means that we don't need to have rotation in here. And then, oops, in here, we don't need to do any of this shit here. We don't need to do any of that. So boom, 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 boom. So then we can just get rid of it. We just get rid of it. And then in each if, we're going to change the value of the angle. That's what we're going to do. The default angle. Yeah, we need to save the angle. That is the case. So there's going to be an angle. I'm going to that's kind of I'm going to just call it the angle for now. So let's say that this starts with choose with this. Let's say that. And then in here, we can get rid of it. Yeah. Then, so something got messed up. Yeah. So actually, let's bring this back. And then we're just gonna do boom, 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 boom. We're gonna
Funny,
save
there's
this.
a function that takes an axis and an angle and returns a quaternion. I mean, those are two different ways to encode the rotation, so it kind of makes sense, but
Okay, and now we're gonna decide what the heck we should do. Yeah. Okay.
and
We
apparently
know
quaternion is an alias for vector 4. Vector 4 is a terrible name.
it is 100% consistent with the rest of the nomenclature, so I'm 100% fine with it. And then in here, this is always gonna be height axis. Yeah. So now here's the kick. Walking forward is 270. And if walking forward is 270, what the heck is the other ones? So walking to the left. I'm gonna guess this is 180. Which means that walking to the right is gonna be 360. Walking backwards, walking backwards is gonna be 90. This does absolutely no difference. So this should be the
360 equals
same.
0. Yeah.
And the control to basically the height again, this doesn't change at all. Is that it? I wonder. That seems to be it, believe it or not. Which is kind of surprising. What the heck is model scale? Oh, this is the model scale. This is also a constant. So we can remove it from here. You should leave in like some sort of constants of the game at some point. But this should not be called in every single frame. Cool. So this should be character position. And this should also be character position. And then we do that. We do a little bit more of that. And that's kind of it. Let's comment this because we're not going to be dealing with the server today. So can we compile? That's kind of a good question. So state.zig. Yeah, so it broke as expected because there's no messages.character anymore, which is expected next error. So it's saying that in character 159, oops, 159,
I'll be right back.
Uh-huh. So this is for the allocator. This is for the allocator. We do have game state. Okay. So we should be able to just do game state character. No field 163. 163. Oh, I see what that was. That's a terrible name. Terrible. Freaking terrible. So this is like the thumbnail of the character. Alright. This is kind of the thumbnail of the character. What do I call it? Preview or thumbnail? I'm gonna put preview. I'm gonna say that this is a texture 2D. Yeah. And I'm gonna also say, well, I need to say, does that make sense though? Complicated to guess this. Very complicated. Okay, let's not make this optional. Let's not make this optional. Let's just say that this is a preview. And then
And I'm back.
we're not gonna be able to do that. I figured out what was the equipment data. That was just a
Oh,
terrible name. Terrible. This is the preview. This is the thumbnail when you're selecting the character.
oh, I see.
So that was really, really bad. Really, really bad. So, we're gonna basically do data here. We're basically gonna do data, which begs the question: the data should not be initially something. It should never be initially something. That makes sense. And then this thing, this is the preview. This is a preview. Cool. So what is the next thing? So state 52 got messed up. 52. Oh, I see the problem. I see the problem. Yeah, we don't have a character yet.
We don't have
So
a character
this
yet.
needs to be this. This needs to be this. So now the character is optional, which means, which kind of means that we're gonna have to check in every single fucking place. Ah, boy. Boy, oh boy. That's very fucking unfortunate. I'm gonna have to do this every time. Okay,
Hmm.
so game state. But I guess it kind of makes sense in a way. So
Does
this
it?
is the character. How do we need to put a pointer here or something?
Uh,
And
the,
then we do model.
I mean, I guess we should, right? We don't want to copy the entire character here.
And then I need to do this.
No, you don't.
It will be automatically dereferenced for me.
Yes, because if it's a pointer, well, the pointer doesn't actually have a model field. So the only way you can make sense of that is by dereferencing the pointer.
Mm-hmm.
So Zig does it for you.
So I think this entire thing needs to have an if
That's
character.
kind of sad, to be honest.
That's very sad, right? This is very fucking sad. Uh, we're gonna have to put all of this, all of that, and then we can just boom, boom, and then I'm gonna replace string everywhere that we have game state character, replace with character. Yeah, that's very sad. Okay, here next here. Okay, so it is not a use size. It's actually kind of cursed.
It's not a use size.
It's F32.
What? Why?
Well, I guess it's because you can have like decimals in the angles or something.
I guess. By the way, you don't need to put the point zero there because since you are already saying the type is F32, you can figure out, yeah, this should be a decimal.
Cool.
Well, not really a
So
decimal because floating point is binary scientific notation, but you get the point.
I get the point. So this is actually character data dot name, which data is actually not a good name now that I think about it. Uh,
It's too generic. Like, it could be anything.
yeah, this is actually like stats. Yeah, I actually go back and refactor that already before I have to change more places. Stats. Yeah, like, that makes a lot of sense. So stats. Um, what the heck is going on here? So this is going to be stats, and this is also stats. And at the bottom here, this is stats, which basically means that this is also stats. Let's see what breaks. So 165, of course. Next up. So it's saying that optional type does not support field access. I see the problem. So it's basically telling me, brother, you need to have a character. You kind of need to have a character, brother. So same thing. So game state, character, character in there. And of course, these shadows. Boom. Okay, so 26. This is wrong because this is actually preview. So 70. 70. Uh, this sucks. This sucks. So the texture.
The
Okay, we're
texture.
gonna have to make a choice here. What is less worse? We allow the character struct to all of the fields to have default values, and then we don't need to be asking if it's null because then we can just say there is a character in there, and then we just populate the fields as we go. Or we keep the character nullable and have some of the fields like not allowing to have the full value, such as the character info and the preview, and then we need to ask if this is null every time.
Or we change the structure of the game state and then we make sure that when we need to have a character, we have one, and otherwise we don't. Although that would probably be more complex. Well, more effort, I would say.
I think what you said is one of the options that I said. Like, what you said is we need to ensure that we only have a character when we are supposed to have a character. But we need to tell the game state that there should be eventually a character, so we are making it nullable. What I'm asking is, what is the best way to portray that in the implementation? To have an optional, and then we need to keep asking it all the time? Or we have the full values for all the fields, and we can just have an empty character? What is better, an empty character or a nullable one?
Hmm.
In terms of like the
Hmm.
business rules of the game, it should not be possible for you to have empty stats. That's why I was against doing this.
We should probably have a nullable character.
That sucks.
Actually, let me amend that. We should have a nullable pointer to a character.
A nullable pointer.
Yes.
Uh, but then we're gonna have to allocate the character.
No, we already have a character allocated in the character list.
Dude, okay, let's do the following. Uh, that's gonna take a lot more effort, I think. So let's say change this to be a nullable pointer. Because that's the thing, I want to garbage collect this. That's why I think a nullable pointer may be bad.
Oh.
Because I don't want to save the stats of the characters that you're not playing. You already chose one. You're already playing one. Why
Well,
should
in
I
that
care?
well, in that case, what if a part of the game state is a union, and then depending on the specific game state that we're in, whether we're playing or in the character select screen, the union contains different things, and in one case it may have a character list, and in the other a single character, and then we don't have to bother with a nullable character because the union will tell us, hey, you have a character.
That's actually a very interesting idea. Uh, actually a very interesting idea. But here's the kick. You see that if you make the game state a union, we're gonna have to have game state. We have
We
to
don't need to
transpose the state from one stage to the other.
we don't need to make the entire state a union. We can make a single field be a union.
No, no, no. I agree with that. I agree that not like for instance the width and the height they will be available for everybody.
Yeah.
But what you're saying.
Look, we already have an enum for the current screen, right?
Yeah.
We can just make that enum into a union.
Hmm. That's very interesting, but that's gonna take a lot more effort. So let's make it to do. So right now, let's just follow with the nullable character,
Okay.
and then later on we can figure out. So to do, make this um, a tagged union.
A tagged union, indeed.
Make this a tagged union in which we have different data available
For each
uh,
screen.
uh,
For each scene, I guess.
per scene. So we can have more guarantees of what is happening with the data based on the scene we are in. this should allow us to not have nullables everywhere since the data is not there yet. It is yet to come in another future scene. Cool. That's cool. Let's continue.
That sounds like that's a very compressible piece of text, Lemos.
What do you mean?
It's very compressible.
Compressible. So you think we can synthesize it better?
Yes. Let's not do that right now, though.
Uh, okay, so this is definitely this definitely can go away. Well, if it's well, assuming that it's when you and me, I think this is enough to remind us the reasoning. Okay, so game state, and not actually not that. So character, we're gonna have a character here, and then we're gonna do character name is equal to that, which this is a menu thing. Okay, so I don't know what is that. So no field name. Oh, of course. So there's stats. Cool. So 39. Let's continue the refactoring here. So interesting. Very, very interesting. But this sucks a whole bunch again. Because I'm gonna have to do an if just here. Boy oh boy. That sucks, man. That really sucks.
Data organization, Lemos.
Uh game. Yeah, the whole thing about tagged unions. Yeah, we're gonna have to think carefully about that because there will be some sort of like a can we oh we can do a merge of structs at compile time.
We can, but
We're gonna have to do that because there will be some sort of a base struct that every single value of the tagged union was gonna kind of quote inherit, such as
yeah,
the
no,
width and the height.
dude, you can just let the width and the height be in a struct around the tagged union.
Wait, can you repeat?
Like, if you have data that needs to be available for every screen, you just make a struct, put the union with the data for each specific scene inside of that struct, and then put the height and width of the window, which needs to be available for every scene, in the same struct as well, not the union.
Ah, I see.
Yeah, let's not do inheritance, please.
No, but we are kind of doing it. It's just that it's not obvious, but we are kind of doing it.
No, it's not inheritance, it's composition. Of which inheritance is a special case, I will admit. Okay,
Ah, it is very broken. It is
yeah,
very broken.
something went wrong, I would say.
Something went terribly wrong. To the point that I don't know what we did what we did. So if I go back here, if I go back there, we are calling go to spawn immediately, which means that none of this code matters for now. None of this matters. And we're going straight up to here. And then we're saying, is this... Oh, of course. Wait, of course. Are we... how are we printing this thing? Uh, oh, the camera. Oh, okay, that actually makes a ton of sense. So in the beginning, there's no character, right? So this if never went through.
Yes, if there's no character, we're not entering that if. That is correct.
Okay, I'm gonna do something very stupid. Very stupid. Uh, Man, I really regret the decision that we did of making that nullable there. But okay, we should have gone this route for today. This is the correct route. Um
Making just a preview nullable.
yeah,
Okay, I see. I kind of see it.
because we are jumping it. We are jumping it. So that means that I can just do this thing now, which kind of means that this file is now completely cursed because I just added a bunch of ifs checking if it's nullable or not. So I think the best way to go is to restore that thing. So pit
But
restore,
then you're gonna lose some other stuff as well.
but that's gonna be less work than just like making it, removing the ifs. So let's do that. Uh, yeah, so let's just do that. So then character model, that's gonna work. I don't need to do any of that because I have something better called the compiler. Yeah, so all the way down here, we're just gonna do game state character. We're gonna do stats is equal to stats. Boom, boom, boom. And then we're gonna say that the preview is equal to that. What is the next problem? So main.zig. Yeah, I can also remove this nonsense now. Uh, Thank you very much. And then there's a character position, undefined. Oh, I see. I 100% see. So let's bring that back and say, and change character to game state character. Boom. And then we can get rid of that. Rid of that. That's not. Yeah. And we can go to character.zig and just say stats that, and then we can also say stats next 122. This is the preview, so we're gonna do preview. Ooh, but now the preview is nullable, right? Yep.
Right.
So there
Right.
will be an if here. Character preview preview. And this is broken because we forgot to do that. And we can just do it like that. Next up, so 68. So this is character, stats, name. Next up, 30, oops, 37. Uh, this, actually, probably this. And okay, the left and right are opposite, but that's kind of, there is some sort of effect because it's rotating too fast.
Well, it's
Uh,
rotating in a single frame, right?
yeah. No, but that's expected. I'm not complaining on that. So the A and the D, they are reversed. So this is 180, D and A, and this is 360.
Just make it 0, man.
Okay, that's very fair. Woohoo! Rotation, boys. 1 hour to get rotation.
I think there's something weird going on.
No, man, it's because like there are two things happening. When I press, it's moving and it's rotating simultaneously. So there is some sort of like it feels wrong, right? It feels that something is broken, but it isn't. It is exactly as we implemented. If you want to change that, we would have to have some sort of like an internal inner state manager that would say when you click first, you're just gonna rotate, and then when after you rotate, then you start moving.
That means we will need a facing direction as one of the numbers in the character data, in the
Yes.
character state actually.
Yes. Do you want to do that? Do you want to rotate first and then move?
I think so. And this is basically how Warcraft 3 works, so I'm okay with that.
And this is still working, huh? Yeah, this is still working. It's so cool when you make things that are like kinda ish, not really, but kinda ish complicated, and they don't break other stuff that was working before. The rotation is still working. All the math that we did to for the camera and that stuff, it's still working.
It's magic.
Yeah, it's kind of nuts that this guy is like with his arms up all the time. That's so cool. Okay, so okay, so boy. Okay, so you want to have in the state, in the character, you want to have something like a face angle. uh, okay, let's call it face direction. That's better. And let's say that this also starts at 270. Cool. So here, the boilerplate is going to be insane.
Actually, the facing direction should probably be in Postgres.
Really, I don't really care that much. I don't think that it matters. It's such a tiny thing.
Here's the question: do you want turning around to be a mechanic or not?
Yes, but not in the sense that it only cosmetic in a cosmetic way. When
Okay,
you
so it's not
load
so it's
up.
not actually part of the physics that you have a facing direction. That's just an artifact of how we render stuff.
Oh, I see what you mean. When you throw like a fireball, it's gonna use the face direction to know where to fire.
Yeah, like
But what
suppose
about
you
the
have
mouse though? Shouldn't we use the mouse to do that?
no. Here's the thing. There's a difference between I'm facing in a certain direction versus I'm hovering my mouse to aim a certain direction. Like, uh, I don't. You wouldn't have had the occasion to play Dota at some point, or Warcraft 3, or
No,
I
no.
guess
But in those games, the direction of the character doesn't matter.
it does actually.
No, in which Dota are you talking about? Dota. Dota 2?
Either Dota 2 or Dota 1, they have the same mechanics with regards to facing direction. Like, each character has the direction that they are facing, and they have a turn rate, which is not instant. You take time to turn around, and you can
Mm-hmm.
only move in the direction that you are facing.
Okay. Okay. Uh, that's the
League of
thing.
Legends doesn't have a turn rate,
That's
as
what I
far as
was
I know.
thinking. Yeah, League of Legends, I think some abilities have, but the majority doesn't. It's kind of complicated. But it's been years since I played that. So here's my proposal. Here's my proposal. Because if we want to make the face direction matters for the game mechanics aside from cosmetics, we
That needs to
need
be
to
on
save
Postgres.
on Postgres.
Yeah.
And I don't really want to do that right now.
Okay.
Uh, I kind of don't really want to do that right now. Let's implement the two ticks necessary to start moving. Agree?
Okay, let's do it.
Cool. So my understanding is that we're gonna start this process by asking the angle is the angle
Mm,
ooh
yeah, there needs to be a certain
mm.
range.
No, what I
When
want to do is the following. I want to check if they are not the same, because if they're not the same, that means that we're not going to move the character
right, right.
if they are not the same. But that's the thing. I don't think we need to, because if that's the case, we don't need to save the angle anymore in the game state. We don't need to do that. Because now we only care about the face direction.
Well, the face direction and the angle are kind of the same thing, right?
No, they aren't. The angle is at the moment. It's when you press it. There is a number when you press it. The
Okay,
face direction is the one that we saved from the previous tick.
okay, I get it, I get it.
So we're gonna have this now, and then in here, uh, instead of changing that, we're just gonna change the angle. Well, I did it wrong in there, but that's okay. We're gonna change it anyway. So then I'm gonna do
It
that.
can't really be just a simple. Oh, okay.
And then after we define what is supposed to be the angle, we're gonna we're gonna oh, but we're also changing the position.
But we're also changing the position. Yes.
That sucks. But okay. Let's make a temporary position. So this is gonna be temp position. That's gonna be temp position. And this
Ten
should be a
potential.
copy. This should be a copy, not a pointer. This should be a copy of the current position. All right? I'm
All
assuming that
right.
that's gonna work. Yeah, this only matters for these cases. So we're gonna do this. Okay, so we know what we are supposed to do if we're gonna move this stick. If we're gonna move this stick. Now it comes the gotcha. If if we know that the game state character face direction, yeah, if this is different than the angle, what we're gonna do? We're not gonna move. We're not gonna move. That means, yeah, this is gonna work. This is gonna work. We're gonna do two things. We're gonna first draw, and then we're gonna update. We're gonna see this is now the value of the next stick.
Okay.
Uh, yeah. If they are equal, we're gonna do exactly this. If they are not equal, that means we're gonna use the previous. So that's actually very annoying. Let's do that. So const previous. Uh, this is very long and very annoying. Uh, so let's say previous, and I want this to be a pointer. So I guess I need to pick the reference, right?
Yes.
Cool.
Although you're gonna need to dereference the pointer anyways in order to do the comparison. So
Yeah, but only that. And then here, I'm gonna say that the value is gonna be angle, and in here, this is previous. Boom. And that just works. If they are the same, we're just gonna use the new angle and the new position. And the new position, which kind of means that we need to pick the position here. So game state character position equals the new position. And then in here, we're gonna draw the new thing moving. And that's it. That should work.
okay.
And then we don't need this anymore. we don't need that. So use of undeclared identifier position. So what are you not liking? Oh, I call it position. Temp. And for the sake of how can I say consistency, we're gonna call this temp angle. Boom. That's what we're gonna do. And something got really broken. Really, really broken. Yeah, the temp position got nuked. So let's F32, choose 70, and this is gonna be temp position, which is gonna be a clone, not that, of the game state character position. And that should just work. Use of undeclared position, that makes total sense because now this is temp position. The same applies to this temp position. Okay, I'm gonna press to go to the left. Let's go.
What?
It is going back to the yeah. It is going back to the original 270 for some reason. And I don't really know why. Oh, I know why. Because this should not be that. This should be game state, character, face, direction. And it should be as a copy as well. Okay.
Nice. It remembers the facing direction.
Yeah.
Still feels kind of wonky though.
I think we need to have more frames. We are just doing one. You see? You see what I mean? You need to keep pressing a key more time in order to activate the actual changing of the direction. We are doing for only one frame.
No, I think that's okay-ish. The main thing that's bothering me is when you start and stop moving, it feels kind of janky.
Yeah, it feels like we have a hard stop, right? We have a hard stop. So that's actually an interesting thought because we have interpolation functions in Raylib. So it should be possible to lerp,
Lerp.
and then we kind of like we can smooth the thing out. You know what I mean?
Yeah.
Because when I stop moving, it just like it stops. But how are we gonna do that?
Uh,
How are we gonna know that if a key is not being pressed anymore, we should, huh?
we just need to interpolate between the direction we're currently facing and the direction we're supposed to face based on the key that we're pressing. And if we're not pressing any key, we don't touch the facing angle at all.
I don't understand. If you're not pressing any key, I don't think that's the problem at all. I think it's because once all of these ifs are not true, we're just gonna have a hard stop. We need to smooth out, like after all of those things. After all of those things, if none of this is the case, we need to smooth the to be less abrupt. You know what I mean?
Let's try something. What if you change the movement speed from 2 to 0.5 or something?
Sure. What you said is to smooth out the transitions between directions.
Yeah, but like that's not really what bothers me the most. It's what I thought you were talking about, but that's not the case at all. That's pretty slow.
Yeah. So
And
maybe
it's still
one.
doing and it's
It's
still
still
doing
doing
the
it, right?
yeah, it's not really the hard
But
stop
now,
thing. It's
yeah,
that
but because it's slower, it's less noticeable.
no, but it's like when you stop, it's snapping. You know, like
Mm-hmm,
you know
mm-hmm,
like how a magnet it snaps to metal when you approach
mm-hmm,
it. It
mm-hmm,
feels kind of like that.
mm-hmm, mm-hmm. Yeah. Oh, I have a solution.
Okay, go on.
Um, okay, I actually don't know if well, I have the solution. I don't know how to implement it, but we can because we can lerp it. We can lerp it because lerp is linear interpolation between the two things. We know the direction because of the phase direction, right? So we know what would be the next position that we were supposed to go if the key was still hold down, right?
Right.
We can lerp between the current position and the one that we were supposed to go by like a pixel or like I don't know whatever amount we feel it makes sense. The problem is that the start is not a float; it is a vector.
Hmm.
So how to do that? Oh, vector 3 lerp. Maybe. Do you have lerp? Yeah, vector 3 lerp.
Lerp.
Yeah, actually. Yeah, man, that can work. Okay, the code's gonna be horrendous, but that will work. That will work. So what we need to do? We need to
Why
do.
why is it called lerp, by the way? That's a weird way to abbreviate linear
No, it
interpolation.
isn't. It is linear interpolation. So you do this, and you do this.
Why lerp though? Like that's not the beginning of interpolation.
It's not about being the beginning. It's about having a short and memorable name that is the combination of the two words. Yeah. No, well, the code's gonna be janky as fuck. Okay, that's very unfortunate, but it is what it is. So we're gonna do the following. So var key pressed, and this starts with a false. This starts with a false, and I'm gonna assume I'm gonna have to pass the type. So in every single one of these cases here, we're gonna have to do key pressed equals true. So then, yeah, I'm only gonna do that for the 2D directions, not jumping and going down for now. Then what we're gonna do? We will do an if on the key pressed. Actually, if no key was pressed, that means we need to lerp on the temp position. That's what it is. How are we gonna do that? We're gonna do an if asking if the temp angle if it is equal if it is equal to a certain angle. So yeah, there's definitely a smarter way of doing this, but for now we're gonna do the naive, innocent way. So if this is the case, what we're gonna do? We're gonna do temp position is equal to ram vector 3 lerp lerp. I think that's the convention in Zig, right? Yeah. We're gonna lerp. And what we're gonna lerp with? We're gonna lerp. We need. Yeah. We need a thing called const, not const actually, var future position, and we're gonna say that this is equal to the temp position. This is a copy of the temp position. This is a copy of the temp position. That means that we're gonna be able to remove this from here, and this is gonna be temp position and future position. Let's say 5 for now. And then in here, we're gonna say that the future position 270 is x. We're gonna say that you were supposed to decrement in here, and then there will be a temp angle, which is gonna be equals to, I don't know, 90, and then we're gonna say that the future position x is supposed to be plus. Are you following, Marie? What I'm doing here?
Yeah, if the key is not pressed, we.
And then this is going to be z plus.
Yeah, that makes total sense. And then we just do a lerp, and we use that to hopefully not have the abrupt stop and snap that we were seeing before.
I'm
Hopefully.
very skeptical this is going to work, but let's see. Uh-huh. Oh, it's not boolean, it's bool. Oh, of course.
What
It is just moving
happened?
forever. Oh, it's lerping forever.
Hmm.
We need to
Okay.
save if we press in the last tick.
We do actually.
That's getting janky as we go. Jankier and jankier as we go. Uh,
Actually, doesn't Rayleigh do that for us already?
in which sense?
Like,
Key.
yeah, is key down, I think, is what we want.
No, but we are already using is key down. Look.
Not that
Oh, we
one
want
then.
key released.
Key release, yeah.
So that means that we don't need this. And then instead of doing this thing, but I want any key. Now what? Now what? Oh! No. There is a smarter way. We are just stupid. Okay, so here's the deal. We're gonna copy all of this and paste it like that.
Literal copy paste programming.
Literal copy paste programming. We're gonna grab this and also put it in here, which kind of makes this a little bit. It seems very silly, and probably there is a very smarter way of doing this, a more clever way. But I'm not
No,
in
no,
a
no,
my
no. We don't.
most in my
We
most.
don't. We don't want a
Wait.
more clever way. We want a simpler way.
Okay, so choose 70. So you go here. You go here. Bye, everybody. So the 90 is here. So we're gonna put it in there.
Running through the
The
90s.
0 is this one. So we're gonna put it in there. And last but not least, the 180. The 180 is here. So we're gonna just do that. Cool. We're gonna maintain the lerp, of course. But we can remove all of that.
Oh, it's running in the 90s, not through the 90s. Okay.
And then in here, replace string down release. Yeah. And we are only doing this for the sides. So this also can go. This also can go. Okay, let's test them. Oh. Raylib has no member key released. What?
Huh.
Am I stupid? Wait, what?
Oh, you're missing a D at the end.
Oh. That's not the correct.
It's somehow worse. Also, we're going backwards. Apparently.
I'm going backwards. I am going backwards. Why? Okay, maybe the amount is too little. That is the reason. Maybe we need to put more. But how are we going backwards? So when I press D, I have Z with -2. When I press A, I have Z with +2. When I have W, I have X with -2. And when I have S, I have X with +2. I don't understand. I don't understand. How am I going backwards? What? Was I really going back? I was going backwards, I remember. I'm going right. Woo!
What?
Now we are lerping. Okay, 20 is a little bit too much. Lerping a little bit too much. So what about, I don't know, 5?
Okay.
How am I going to to the wrong thing? I don't
Epilepsy
understand.
warning, I guess.
Uh, oh, it's not. The answer is not too much. We need to do less. Okay.
Yeah, it's still snapping, but it's less. That's better.
Okay, but I did 0.5.
Yeah, maybe get rid of the key release because you're sliding backwards when you stop.
I don't. No, but if it's not key released, how are we gonna do it?
Uh,
Oh, check if a key. Oh, wait. There are some documentation. So check if a key has been pressed once. Check if a key has been pressed again. Check if a key is being pressed. Check if a key has been released once. Check if a key is not being pressed. To me, we're still on the released ones. Am I wrong?
scroll left a little bit. Yeah, that's the right function, I think.
I don't think I'm sliding backwards. I think it's just an illusion to you.
No, you really are sliding backwards because, wait.
I don't think I am sliding backwards.
If is key released,
Very hard to tell if we are. Oh, my spacebar is not working.
huh.
Interesting. The spacebar is not working. How? How is the spacebar not working, brother? Brother?
I don't know.
That's very weird. Okay, there's something with this logic here, which is saying that the previous is different than the temp angle or something like that, and then we are not able to do the thing, but I don't really understand. I don't really understand, brother.
Hmm.
Brother. I don't know if I'm getting the problem, man.
Hmm.
It's getting worse. Why is it getting worse?
Oh, it was kind of tricky when you were moving diagonally.
And I cannot jump anymore. Why? How is this broken? We didn't change anything.
To be fair, we could never jump. We could only float and sink.
Yeah. To be fair.
Let's see.
but,
10th
but but
position,
how, dude?
50th
How is this
position.
not working? I don't understand.
We set the position, but then 10th position is lerp, and then previous is equal to the 10th angle. Otherwise, scroll down a little bit.
Well, one problem at a time. Do you have any ideas on how to fix the space? Do you have ideas on fixing the spacing on, well, the
It's
floating?
the else. It's the else is the
What is wrong
problem.
with the else?
We're setting the position to the 10th position, but the spacebar is still setting the position, the original position directly, and it's getting overwritten by the line 89.
Ah, okay. So what you're saying is that we should put temp position in here. Temp position. Yeah. Thank you, Marin. One
Yeah,
problem at a time.
we still have that snapping motion when we move vertically as well. I think.
No. But let's fix it on the ground first,
Okay.
and when we discover how the heck to fix that, we make it on third dimension as well.
Okay.
So what are we missing? How is the lerp not working? That's what I don't understand.
Maybe we're not actually snapping around, but the camera is doing something weird when we.
Oh, that can be the case. Look at what we're doing here.
Hmm. We should probably do that after we move, right?
Yeah, I think so. So where do we put the position of the camera? Vector normalize, then we pick the camera position, and then we put that. Yeah, so we're gonna pick this and put it after all of that. Is that what you're proposing?
Yeah, let's try it out. See if that improves things. Nope. Apparently not.
I don't understand. When I release the key, it should just do the lerp to advance a little bit more. Huh. Are we missing something? I don't understand. What are we missing?
Maybe. Go back to the code where the section where we're doing the lerp. Okay, we do a vector3 lerp. Take position, future position, points to. Okay. That's the future position. That's the temp position.
Like I am reassigning the temp position to itself, by the way. I'm using the temp position and assigning to a new value.
uh, I have a question actually.
Hmm.
Why are we mutating the temp position on line 60 and above and the future position on line 62 and below?
Because the future position, this is when you are pressing the key. So this is actually when you are triggering it to move. And this is when you are releasing, which is that you want to stop moving, at least in that direction. And what we are doing, we are calculating what you would be, in which position you would be in if you continue to press it down.
Okay.
And the future position and the temp position, they start as the same.
Okay.
So that's why the difference. So this should be an updated imaginary position if you kept pressing the key.
Yeah, you should probably create the copy of the temp position.
The future position.
Yeah, the future position after
Ah,
you do
after
the,
we move. Okay, so maybe that explains why we had the jittering and why you thought we were moving backwards.
because we actually were when the lerp was higher, right?
Yeah. So let's see.
Uh, I mean, it's a little less abrupt, but we're still snapping.
Yeah, but what if we increase, because we were doing like 0 2. Let's try to do something like that. Ooh.
That's a bit smoother.
Okay, so what about 75? Oh, it's the opposite. As we increase it, the lerping is actually
You go
going.
backwards more.
Like go
Maybe,
backwards. What do you mean?
I mean, it feels like going backwards. We may not actually be going backwards, but
Okay, so we were doing 0 1 before. Oh, I don't remember what we were using before. Yeah, the snap is still there.
bye, Fernando.
Bye, Fernando. Hey, what if we, I don't know, put 1 or something? Yeah, now it feels that we are moving backwards. I don't understand. Are we lerping wrong?
Maybe. Skill issue.
Should it be the opposite? There's no way. There's no way it should be the opposite, man.
I don't know. It's weird. It's really weird.
Yeah, this feels worse than before. That's for sure. Okay, so let's insist a little bit more. We have we have a little bit more time. So, what are we doing? If we're pressing the key, if you're pressing the key, we are moving it, we are updating the temp position.
Yep.
Then, if you release the key, we are updating the future position, a copy of the temp position. Um,
Although, is there any case where the key is simultaneously down and released? I don't think so.
I also don't think so. Um, so, so, are we doing the math? Are we doing the mappings correct? So D is minus 2 on Z, A is plus 2 on Z, W is minus 2 on X, and S is plus 2 on X. So if we just release the key, that just happened. What do we do?
Okay.
We,
Still move a little bit, right? Because of the lerp.
yeah, but that's not gonna, yeah, man, it's not gonna fix the snapping.
It's not.
What we want to do is to have a progressive way to like move until the target. You see what I mean?
So like,
Yeah.
I guess what games tend to do is okay. You have you have you have friction, right? Which tends to slow you down until you stop. And as long as you are holding a key, um, you will
Ooh.
you'll be moving at a pretty much a constant speed, right, in the direction you're going. There may be some acceleration until you reach that speed, but afterwards,
Man,
you
that's
move
it.
at.
That's it. That's exactly. We that's perfect. We should
Yeah, and then
stop. We should stop. Well, not that we should stop, but we should introduce
friction.
velocity.
Yeah, velocity and
That's crazy. Okay. So, what should be the velocity? I think we are doing 2, like plus 2, minus 2, everything is 2. So, it should be something like that. Let's not start with the vector for now. Let's not start with the vector for now. So, let's assume that velocity is an F32 and it's going to be 2 for now. It's going to be 2. Cool? Cool.
actually your velocity at the beginning should be zero, no? Because
No,
when
yeah,
you spawn,
you are right. You're 100% right. So there should be a velocity ceiling. There should be ceiling. So let's put this up here. So const velocity uh, velocity ceiling. Velocity ceiling.
which would be like your maximum movement speed or something similar,
Yeah,
right?
yeah. Max move. Velocity ceiling. So now when you, yeah.
Now, when you hold the key, your velocity increases up to the ceiling, and then when you're not holding the key, there will be some friction that will decrease your velocity every frame until you stop, right?
Okay. Um, okay, we have a slight problem. Very tiny. Very tiny. This actually needs to be a vector. Yeah, because we have at least 2 directions that we care. So it's definitely a vector. I'm gonna do v3 just for the sake of it. And this should actually start as you said. We start like standing still, so nothing should happen at all. Yeah, yeah, that's it, Marinho. You genius. Like I always said, everyone needs a Marinho. Everyone needs one. It's good. It's good to have a Marinho. So that means that we should just copy this and the maximum velocity in every single direction should be true. So that's what it means.
Should it be?
Yeah, at least for now.
But that
So
means you can
wait a
actually
moment.
move.
Wait a moment. Then the lerping is going to use the velocity vector and the position vector, right? That's what we're going to do. Yeah. So this should be game state. Character velocity. And let's put 0. Oh, I don't know. I don't know, man. Let's put 2 for now. I don't care. And and when you press a key, what you're actually changing is not the temp position. You're not changing the temp position at all. What you're doing is to change your velocity. You change your velocity. So we're gonna do velocity, and we're gonna say that this is a reference to character velocity. To character velocity. Yeah. And
That could be a const, by the way.
that needs to be a const. You're right. But here's the kick. How are we gonna do the acceleration?
Well, we need to grab the delta t, right? How many?
No, but the delta t we know it's a frame.
But a frame may take different amounts of time to render, right?
No, well, we are assuming that they are constant depending on the FPS.
Okay, so if the FPS drops for whatever reason, we're moving slower.
No, but that's not what we want to do. That's how the old games did it back in the day. The old games were they were using the clock as to calculate the delta t. That's not what we should do at all. That's not what we should do at all. Okay.
Why?
Well, because that's wrong. If your CPU is faster, the game should not run faster. That's wrong.
You are
Uh,
assuming that the clock I'm referring to is the CPU clock, right?
yeah.
That's not the case.
I mean, I don't know how to do that, to be honest with you.
I'm pretty sure Rayleigh has a delta t function or something.
Okay, so you're talking about like delta. Yeah, it does. Get frame time.
There you go.
So what are we gonna do? What are we gonna do with that? Get frame time. What are we gonna do with that?
Uh, well, we multiply that by some acceleration constant, which would be like how
Mm-hmm.
quickly we can change direction or speed, I guess.
Okay, so acceleration. Let's say that is 1. 1.5.
Okay.
So we multiply that with the acceleration. What's next?
Well, that's our delta velocity, I guess. And then we just... Here's the problem. If we just do this the naive way, diagonals will be faster than moving aligned to an axis.
That's fine. We can change this later.
If you're okay with that, then we just need to add the delta velocity um, to whatever direction we're going.
Okay, so you're saying velocity z, it's minus delta velocity. That's what you're saying.
Yes.
I see. So in this will be plus in z. This will be minus in x. Minus in x.
This is plus in x.
Yeah, no, I need to pay attention here because remember the ice cream that I was having before?
Yeah,
It's starting to attract ants.
that's no good.
Yeah, no, especially in a room that is not a kitchen. Okay, so we have all of that. We have all of that. So there needs to be a verification here, which is velocity. Uh, velocity.
Velocity must be the minimum of itself, and
Yeah, but
it's
do we have that in? I really don't think we do. Yeah, no, that wouldn't make sense. So the minimum. Do we have that minimum? Minimum. Uh-huh. Oh, but this is
that,
for drawing. I don't want
that's
to
for
draw.
drawing. Yeah.
I don't want to draw. No.
Maybe it's in the math library.
No, there is no minimum. Oh, wrap input value from min to max.
Oh, that's wrapping. Clamp.
Clamp. Let's clamp it. So clamp. So the value is velocity x.
The minimum is 0, and the maximum is that constant we
No,
defined.
the minimum is itself.
Actually, the minimum is the negative of the maximum, right? Because we can go backwards in the coordinate system.
It's the negative of the max. Yeah, you're right. So this is velocity ceiling, and this is velocity ceiling. And then I
And we
need to
need to
do
do that
that
for all three.
for this and z as well. If I just release it,
Uh,
that's tough.
okay,
Uh,
here's the idea. We need to apply the friction at some point, right?
yeah,
Um,
that's tough, man. That's very tough.
the friction can just be a lerp towards 0, I guess. Although then there's the problem that we will never actually stop, right?
What do you mean?
Because if we just do a lerp, we're going to approach 0, but we're never actually going to hit 0, right?
Yeah. Oh, we are lerping velocity. That's what you mean by never stopping.
Yeah, we need to apply some friction. That should probably come before we clamp, I would guess.
Okay, so you are saying that we should put this after those ifs.
Yeah, and we can get rid of all those ifs. We should just apply friction here instead of doing that nonsense with the key release.
Really? But if I keep pressing, I do not want to have friction. Agree?
Don't you?
Yeah, no. If I am keep pressing, I should just speed up until I reach the maximum velocity.
We can just make. What if we make the friction be half of the delta velocity? Well, actually, that doesn't work, right?
I don't know if that doesn't work or not.
No, it should work. It should work. Because the delta velocity doesn't matter what we're pressing, right?
Oh, which by the way reminds me, this is wrong. Okay, so you want to do something like friction?
Yeah, friction is just some fraction of the delta velocity.
Uh-huh. Let's say a third. And what do we do
That
with it?
is unit spaces, by the way, between the two operands of the operator. And then we just apply it to every. Yeah, we just apply it to every component of our velocity.
Man, that's gonna really suck. I'm not gonna be able to go full speed ever.
You will actually.
I won't.
You will, because the delta velocity exceeds the friction, which means you will keep accelerating, but then we're going to hit the ceiling.
Ah,
That's why
okay,
the clamp needs to be after the friction.
that makes total sense. So what do you want me to do?
Just subtract the friction from each component.
Like this.
Yes.
You want to see if this works? Oh, let's see the lerp first. So what are we lerping from here?
I don't think we need to lerp anymore.
No, we need to do something because we need to update the position using the velocity. I was using the lerp to do that.
No, you can just add the velocity to the position after we have. Hmm.
No.
Actually,
Okay, so you're
that's not
basically
quite.
saying
That's not quite
add
right. We need
and
to
then
multiply the velocity after we do the clamp by the delta time.
okay, so
That's
more of this. Uh, so what you're saying is this.
don't we have a vector multiplication somewhere
We
in
do.
Waymap? Because we can just do a vector multiplication like
Vector
uh,
3 multiply two vectors and scale.
yeah, vector to scale. We just multiply the
Makes total
velocity
sense.
by the delta time and add that to the position.
Okay, so it's gonna be really pretty. Let's see. I'm gonna say that the velocity is rm vector 3 scale, and I'm gonna scale velocity by the delta time, the delta velocity, right?
That should no, actually, we should scale it by the actual delta time, and it's not velocity. It's actually the we need to do position.
Wait, I don't
Oh
understand.
no,
Don't we want to do this?
no, we don't, because this is the delta velocity. This is the acceleration. We actually want to get the delta position now.
Wait, delta position.
Yes, we have a delta velocity. We apply that to our velocity. Now we have the new velocity. We apply that to the position at each frame as well.
Wait, so you're saying there is a new velocity, which it is indeed delta velocity here to the old one, and what do we do with that?
No, no, it's not delta velocity to the old one. It's delta time to the current velocity.
Delta time. Why is it not delta velocity?
Because we're done computing the velocity, now we need to compute the position.
Uh, I'm actually just gonna follow your lead. I'm very tired, so maybe I'm not understanding stuff. So you want to do the vector multiply, right?
Vector scale,
Mm-hmm.
vector to scale, which we get the velocity, we scale it by the delta time.
So we actually need. I still don't understand how it's not the delta velocity, but okay.
The delta velocity, it's in the name, it's the variation of our velocity, but we're now computing the variation of our position.
Yeah, which is just gonna use the velocity, no?
Yes, but the time between frames may vary. We don't want the speed of our simulation to depend on our frame rate.
Ah. Okay, that was I was not doing correct stuff. And then we're gonna add that to the position.
Yeah, yes, we add that to the current position. And that's the new position that should be set on the character, actually.
No, but we're not gonna do the angle thing. We still need the temp position.
Oh yeah, we need the temp. That's right, that's right. You are correct.
Okay, so
Actually,
go on.
yeah, no, you are correct. You are completely
Okay,
correct.
okay. So with this, we are discovering how much space we traveled.
Yes.
That's why it's delta time. I am just stupid. Cool. Var is never mutated.
Yeah,
Yeah,
just
this
make it a
this
const.
just make this a const. Negation. The velocity ceiling is
Is a vector.
it's a fucking vector.
I think there's a vector negate, no?
Uh, well, it should have. Oh, there's the
Well,
subtract.
worst case scenario, we just subtract 0, well, it from 0, I guess.
No, man, we don't need to. We don't need to do any of that stuff. How can I create? Is there uh, where is it? No, I don't want any of that, man. How is there no constructor out of nothing to just pass a number and replicate three times?
Uh, we can scale it by -1. That should work, right?
Scale by -1.
Yeah, instead of doing a minus velocity ceiling, we can just scale it by -1. That should do the same, right? The same thing.
Yeah, no, but I was not talking about that. Okay, friction, friction vector. This is, well, it's gonna infer anyway. At least I hope. Uh,
Well, no, you need to give the type because otherwise it's just going to be an anonymous.
Z. Then here we can just say velocity is equal to rm vector3 sub velocity and then friction vector. And we can get rid of that. And then to do the clamp. To do
Is,
the clamp.
do we have a
Uh,
vector3 clamp? That would be convenient.
no. But that's the thing. This is 100% a functor, but this is C. So,
We do have a vector3 clamp.
where? Am I blind?
Look at the bottom of the page and go 3 lines up.
Oh, here. And even have this thing. Oh,
Yeah,
how
there we
convenient.
go.
A game library that has gaming oriented math. Cool. So let's do that. So which thing are we gonna clamp? We're gonna clamp velocity using rm vector3 scale of the velocity ceiling
And -1.
and -1, and we're gonna use velocity ceiling as the thing. And yeah, so all of this can go away, and we can just swap the vector here. And use of undeclared identifier, blah blah blah.
There's a typo. Ceiling with 2 Y's. What else?
So RayMath
I
has no
think
member vectors 3 sub.
I
I
think
think
it's
it's
actually vector.
subtract.
It's subtract. Yeah.
Uh, so expected type this found a pointer. So I guess I need to dereference those things manually, which is not fun.
You could do velocity dot vector3 clamp as well.
Wait, what?
You could do velocity dot vector3 clamp as long as that is actually a member function, I guess.
Oh, let's try that. I'm actually pretty curious. Can I do? That's gonna be kind of crazy if it works like this, right?
No, 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 no. You need to do equals and then velocity dot. Although I don't know. Let me actually double check the library implementation because
No,
that
we
would
don't
get
need to. The compiler will tell us. Yeah, no member function.
no member function. Okay. Where is it? Here. Vector3.
Scale. What the heck is going on?
I don't know. Let me see.
I am slowly. Yeah, and I'm moving forever also.
Huh.
And I'm going down. I'm going to the in a diagonal, you know?
That's weird. That's
It's
very
really
weird.
bad. Really fucking
Well, it's
bad.
official. We broke physics forever. Uh,
Uh, okay, I'm gonna have to leave for 2 minutes. I'm gonna be back.
okay. Mm,
Okay, I'm back.
welcome back. And apparently we do have vector3 subtract as a member function. It's actually named slightly different. It's just the vector dot subtract because it's already a vector3, so there's no repetition of the type name in the operation name because why would there be?
Okay, let's fix the problem first. Let's make it pretty later.
Okay.
So what the heck is happening though?
Um,
What the heck is happening? So we are moving very slowly. We are.
how are we applying the friction? We're subtracting, right? That's not correct, actually.
What should we do?
We should scale the velocity. We should move the velocity towards zero. If we just subtract, we're moving towards negative infinity. That's not correct.
That makes total sense. So do you want to lerp it then?
No, actually, the friction factor itself is probably okay. The problem is we should negate each component depending on whether the velocity is positive or negative in that direction. Well, no, actually, that doesn't quite work, does it?
I don't know. My mind is frying right now.
Hmm.
I agree with you that subtraction doesn't is not correct. We are actually doing some very nonsensical stuff. It's not subtraction at all. Wait, this is velocity, not positional, not position.
Yes, because this is friction.
And we are clamping to a minimum value, so subtraction should work.
No, it shouldn't because the minimum value is negative the ceiling, right?
Yes, the minimum is negative.
And that means that it's possible for us to go below zero and into a direction instead of actually stopping.
Oh yeah, we need to actually make a minimum again with the zero in here.
No, that's not correct because if we do that, we won't be able to move in certain directions.
I don't understand. If you put a minimum, actually it's a minimum here because in this math can say, oh, you actually traveled negative space. But because there's no notion of like, doesn't matter the signal, we're just gonna go into the floor.
That works for y. It doesn't work for the other coordinates.
I mean, I don't understand how doing a minimum here of zero doesn't work. Should
Because, like, here's the problem. If the minimum is zero, we won't be able to move left
why not?
because left is negative in the x or z or whatever.
Ah, okay. I forgot about that. I forgot about that. Yeah, okay, I understand.
Hmm.
Any ideas? Or should we
Uh,
close for the day and make this another time.
We should close for the day. There's probably a simple solution, but we're too tired to see it.
Okay, I'm gonna repeat the steps for a last time
Okay.
and check if you detect if things make sense. Okay.
All right.
So the first thing that we do is to get the delta time,
We got
and
it all the
we
time.
multiply the delta time by the acceleration
Yes.
to get the delta velocity.
Yes.
Then as the inputs come, we change parts of the velocity vector according to
Yes.
the coordinates of each key.
Yes.
And then we have the friction factor, which is the factor that we're gonna, well, uh, slow down the character.
Yes.
And then what we're doing right now, at least, we are grabbing the velocity and subtracting from the friction. That is
Yes.
the new value of the velocity. And then we are clamping the velocity between the minimum, the velocity ceiling,
Yes.
which is negative, which is the negation of the positive, and we
Yes.
are clamping between those two, and then we are
Yes.
using that velocity, scaling by the delta time to discover how much space have we traveled,
Yep.
and we add that to the position.
Yep. That is all correct, except for subtracting the friction. That one is definitely wrong, but as I said, we're too tired to see the simple solution. So
Which operation do you think it should happen instead of the subtraction?
it should still be a subtraction. It's just the components can't just be friction factor because they depend actually on which direction we're currently moving.
How do we know which direction we are currently moving?
Well, we have our velocity, don't we?
Yeah, so we're gonna check each individual aspect of the velocity.
Yes, if the x velocity is negative, the friction needs to be negated. Um, Otherwise, it just is the friction value, and we do the same for each component.
No, that's actually pretty easy, if that's the
Yeah,
case.
because we basically we want the friction to move our velocity towards zero, essentially.
Yeah, so if I check if this is less than 0, I should pick the friction vector, x, and negate it. I should negate that. I should actually
That
negate
doesn't
that.
quite work actually, because then we can overshoot the zero, which wouldn't be ideal.
No, but wait, overshoot the 0 you said.
Yes, because what if our velocity is one,
Hmm.
and the friction factor is greater than one, and then even if we get the sign correctly, we can still go past zero. We don't want that.
Doesn't that mean that we need always to make sure that the friction factor is always less than the velocity?
Less than or equal to in magnitude, actually. Like,
In magnitude, no, I'm talking about in magnitude. But the delta velocity depends of the delta time and the acceleration.
that's not the delta. We don't care about the delta velocity for this. We care about the. Well, we kind of do because we are basing that on the. We're using that as a base for the friction factor. But we actually don't care about the delta velocity itself. We care about the actual velocity at the moment.
So this should be, I think I know what you're talking about. This should be a clamp between whatever we think it's gonna fit and the magnitude, which is probably vector 3 magnitude of the velocity or something like that.
Mm,
We should never be able to overshoot.
yes, but
Hmm.
yeah, I
Yeah, so something like this. We try to check if the delta velocity divided by 3 is between 0 and the velocity and the magnitude of the velocity, right?
uh, No, that's not quite right. What I mean by magnitude is not the magnitude of the entire vector. It would be like, actually, it would be the absolute of a given component. That would be more correct because
Ah, okay, so you're talking, I see. So you're talking about doing like this then. Boom, and then grab. Actually, I don't need that. And then I'm just gonna do the following. I'm just gonna do rm clamp. Oops, rm clamp that 0, and then velocity pointer something, and then boom.
we don't really need the dereference explicitly there, but okay.
But you said absolute value, right?
Yes, because
So I need
here's
to
the
make an ABS here.
yeah.
The Zig has one.
Does Zig have an absolute value? I think it does. Let's see. And I think it's a built-in even. Language reference. ABS. Yes, it's a built-in.
Okay, so ABS. Oops. So ABS on that.
Yeah, and then you need to set the sign afterwards, which depends on the sign of the. It needs to be the opposite of whatever the component happens to be.
Wait. Repeat that. So we're now guaranteeing that the friction vector will never overshoot.
Yes.
We are guaranteeing that. What what is there left? Um, uh, if the velocity is negative, we need to negate the x component of the friction vector.
Uh, if the velocity is negative,
The
yes.
friction needs to be positive then. Agree?
If we replace the vector tree subtract with an addition, that may be easier to reason about. Because basically, yes,
Mm-hmm.
because if the velocity x component is negative, then the friction needs to be positive in the
Positive.
x, which is otherwise it needs to be negative. Yeah,
No, but it is always for. Oh, I see what we're doing. Yeah, this is gonna
yeah.
look really ugly, but I think it's gonna work. But we can
Well,
make it
no,
pretty later.
actually, we don't need to do the two-armed if, because if we don't need to negate it, we can just do nothing. That works.
We just need to do nothing, you said. So if it is positive, okay, so you need to do the opposite. If it's positive, we negate it.
Yes.
Okay, so minus x.
And we do that for all three components, basically.
Okay. Like that.
Like that.
Is that it?
You don't need the dereferences on the ifs, but yeah, that's it. We're standing still. We can't move. No, wait, you can. It's just we're going. We are accelerating really, really slowly.
I don't know if you're accelerating at all. I think we already hit the limit.
Yeah, the limit needs to be higher, definitely.
Okay, so let's make that happen. So the ceiling for... I think my is not gonna like this feature, by the way.
Why? Why?
Because this is very not old school style games. Uh, should we bump up the acceleration as well? Why not? Okay, that's very bad.
Yeah, the
Uh,
acceleration needs to be way higher.
Okay, let's go all the way to 10.
And we need to bump up the maximum speed as well.
Yeah, that's really bad. I think it's the numbers that I'm using are just stupid because I was using position, like raw
No, the
position.
problem the problem is that before we could move 2 units per frame. That's 120 units per second at 60 frames, right?
Ooh, we have some drifting now.
Well,
Interesting.
yes, because of
Because of the math.
iner- because of inertia essentially.
Not inertia. Well, it's inertia plus the friction factor. We are losing energy in the curve when making a curve until eventually we just go to one direction. That's so cool. Okay, this is still very not.
Just bump it up all the way to 120. And the acceleration can be at, yeah, 60, whatever.
Oh, there's some. You see what happened there?
Yeah. This would be very awesome if we were doing some kind of naval strategy game or something, like a
Okay,
boat
I think we need to
simulator.
be able to finish, like to make our movements a little bit more abruptly. So I'm gonna bump up the acceleration. Yeah. At the point that the acceleration is equal to the velocity, yeah, we start moving immediately in that direction. Yeah, the friction factor needs to be a little bit higher.
Yeah, okay.
Okay, so
Maybe make it half instead of 1/3.
dude, it works. It is smooth as fuck. Okay, but this is actually a little bit also a little bit too much. So, um, ooh. Okay, now it takes a lot to bump up to max speed.
That's because you made the friction very close to the acceleration, right?
No, the acceleration is the same as the velocity ceiling.
Yes, but the friction being 80% of the delta velocity means it's effectively 80% of our acceleration.
Yes, that is the case. Which number do you think is going to work best?
I don't know. We're gonna have to fiddle with the numbers. Maybe tweak. Maybe not make the friction be so realistic. I guess because that works, but it doesn't feel good, right?
I actually disagree. I think it's kind of in these type of games with isometric cameras, it's kind of very, well, at least in my experience, it feels weird that I stop pressing the button and the character takes a while to actually stop. Again, I can see Magetta disliking this a lot.
Maybe make the friction really, really high, like even 1, but only apply it when we're not pressing anything.
Only apply it when we are not pressing anything.
Yeah.
How to do that?
Maybe we set the friction factor, not the that thing. Maybe we set the friction multiplier. Um, Make a var before we do the key press checks, okay? Oh wait, but that doesn't quite work because we want to be able to stop moving in the direction we're not pressing.
uh,
Yeah, let's think of something better some other time.
well, we
I
managed
don't
to make
think.
it work. We managed to make it work.
Yeah.
I'm already very happy with that. Like, it's not the end of the world. Like, it's not bad by any means. It is just uncommon to see this type of camera and the fact that I can speed up and then I release the key and the character is moving by a lot.
No, Mageta's gonna love it. It reminds me of a little bit of Sonic.
Well, that is true. Reminds me of Sonic as well. So we have rotation, we have physics. Yep. Uh, I had fun. Like today was not like we didn't do a revolution of features, but we did quite a bit.
Physics. Physics.
Physics time. Okay, I'm gonna finish the recording now.
Bye bye.